So as I always said that we need three types of people in this business. We need people like us who can make new materials, because in the end, with existing technology, you can only go that far. Only with new materials you can go much farther, right? B, we need people who understand the device physics. So by understanding device physics, you will be able to find out is that how the materials will behave in the device configuration, how that will correlate with specific property of this polymer. So that will essentially give us feedback how we can design the materials better. For example, this material is not soluble, okay? Electronic property is great, but it's not soluble. So but then they bring the information to us. We're going to say, okay, we're going to try to put in more side chains on the polymer backbone. Essentially, you're binding more balloons to the brick, so it's going to be floating better, right? So the same idea. And that's what I said. You need a material scientist, you need a material synthesis chemist, people like us. You need a device physics guy. Then third thing is that you need a physical chemistry guy, PChem, because the mechanism of organic solar cells is different from inorganic. So the inorganic, when light comes in, you generate electron holes right away. So essentially, you have the two different charge carriers being generated in situ. And it's because the inorganics usually have a much higher dielectric constant. So the charges will be able to screen off from each other, so they will be able to separate. Right? So if you positive charge goes in one direction, negative charge goes in the other direction, you end up with electricity. So light comes in, electricity comes out. That's great. So the inorganics is different. Inorganics is different because when light comes in, you're not generating electron holes right away. You're essentially generating something we call exciton.